Hi, in this video, we are going to look at the relationship between price of a bond and yield to maturity of a bond. If we look at this graph, we can see on the x-axis there is the yield to maturity or YTM. On the y-axis, you have price of a bond. Now, if you see the graph, as your YTM or yield to maturity increases, the price of a bond decreases. Similarly, when your YTM or yield to maturity decreases, the price of the bond increases. So this means there is an inverse relationship between price of a bond and yield to maturity or YTM of a bond. Let's try to understand this with an example. Let's look at a bond that matures in 5 years with a YTM of 6%, par value of $1,000, and a coupon of 10%. A coupon of 10% on par value of 1,000 is $100. 10 divided by 100 times 1,000. Coupon is always calculated on par value or face value of a bond. So the timeline of cash flows of such a bond would look like this, where if you were a lender, you would get $100 of coupons starting from year 1 every year up to year 5, assuming that the payments are annual. So $100 in year 1, $100 in year 2, and year 3, year 4, and in year 5 again you're going to get $100. The par value or face value of $1,000 will be received by the lender in year 5. Now, if you key in these numbers in TIBA2 Plus financial calculator, you can key in your coupon or payment, which is nothing but these $100 in year 1, year 2, year 3, year 4, and year 5 are nothing but annuity payments. So you can key them in as payment in your financial calculator of $100. Your par value or face value is nothing but your future value because it comes in the last year, year 5, as $1,000. Your N is 5. Your YTM or I by Y is 6. Your present value, that's what you need to calculate, right, is negative 1168.50. It's negative, remember, because you are the lender and you need to pay it at the beginning in order to get all these cash flows later. So it's an outflow for you at the beginning. So the price is nothing but the present value. So the price happens to be 1168.50 that you just computed. And your YTM is 6%. Now let's just change the YTM in that example, keeping the other things the same. Bond matures in 5 years, same par value of $1,000, same coupon of 10%. Coupon of 10% is 10% on $1,000 of par value, which is $100. So the cash flows will look like this timeline of cash flows: 100 in year 1, 100 in year 2, so on and so forth up to year 5. And you would get $1,000 of par value at the end or at the maturity period in year 5. And when you key in these numbers in TIBA2 Plus financial calculator, your coupons are annuity payments, like I said earlier. So you would key them in as payment of $100. Your par value or face value is the future value. You would key them in as $1,000. N, which is your maturity period, is 5. I by Y is 12. So you compute your PV and you get negative 927.90. The PV is nothing but the price. So the price is 927.90 and your YTM is 12%. To summarize what we saw in the example, other things remaining the same, meaning your par value is 1000 in both the bonds. Your coupon is 10%, which is $100 per year in both the bonds. And it's a 5-year maturity bond in both cases. So the only change there was the YTM. In the first example, the YTM was 6%. So when the YTM was 6%, the price was 1168.50. The YTM increased to 12%. The price decreased to 927.90. So when the YTM increases, the price decreases. If you see it the other way, when the YTM was 12%, the price was 927.90. When the YTM decreases to 6%, the price increases to 1168.50. So now you can see why we say that there is an inverse relationship between price of a bond and YTM of a bond.